Good morning, afternoon, or evening, whatever time you have decided to turn on this online video lecture. Today we are going to be discovering all about how we in the developed world treat water. This is a general reminder, though, that undeveloped worlds or third world countries often do not treat water. Therefore, anything that is suspended in the water, be that visible or invisible, is still in the water when they drink it. That is why they are more susceptible to waterborne diseases, illnesses, and sicknesses. So feel very blessed that you live in a nation where we generally treat our water. Let's get into it though. So our notes right here, they look like this if you've got your notebook handy and open. They are 2 pages condensed into 1 page. You're watching this video lecture, so you've already seen this, and then we have an editable version of our notes. Just a friendly reminder, you want to file, make a copy of this document in order to edit it so that you can too fill out your notes. Let's jump right into it, shall we though? So we've learned in the past all about water quality. We learned about pollution. Now let's look into how we treat our water. For our Bill Ringer question, predict where the water in your faucet comes from. Now, you might have already known the answer to this question if you did your research really well in our river basin activity, but this might also be a guess for you. Now, I don't know exactly where you live, but I've got these handy dandy little charts. I click them, it's going to take me where I want to go. So this is a map of Bladen County, specifically the East Bladen County Water District, and it shows you, no, we're not interested in the purple part, we are interested in the yellow part, which indicates water supplied by cities and towns. So you would have to zoom in pretty far to be able to see where you live, but if you live anywhere here in Elizabethtown, Dublin, Tar Heel, Bladenboro, White Lake, you can see that your water is covered by the city. If you live anywhere else, it is hang on, let's back up. So if your water comes from the city right here, that means that your water generally goes through a water treatment plant, where it is recycled and reused, the bad stuff taken out, and you continue to use the same water over and over again. It's a process we've been doing for quite some time now. If you live outside of these yellow lines, whether that be in the purple right here or anywhere in the surrounding areas, you generally have well water, or water that comes from an underground aquifer. We can look at the West County, depending on where you all live. And I'm sorry I did not do Lumberton County, but you can see it a little bit right here. So if you live inside the town of Lumberton, you generally have, again, city water. You've got Bladenboro, Clarkton, Dublin, Tar Heel as well. And then even where Miss Blake lives out here, she has city water too. Good. So we're going to distinguish. For the most part, we're talking about water treatment, so that means the people that live within these yellow districts right here. But we're also going to discuss just a little bit what it's like for people who live outside those districts as well. So this is water treatment. Here's where your notes start. So looking at water, you might think it's the most simple thing around. Water is colorless, odorless, and tasteless. But that's not true. It's not very simple at all. It is vital for all life on Earth. You know this. We discovered this when we read our water scarcity article. You know all the different properties now of water. It's a very diverse molecule, and it's got a lot of interesting characteristics and tendencies. The thing, though, about water when we talk about humans, livestock, and crops is that we need it. Everything that's living needs water. So where there is water, there is life. Where water is scarce, life struggles or just throws in the towel. Therefore, water is life. So we know when we're looking, say we're looking for a new planet to inhabit, or perhaps maybe looking for aliens, the first thing that many scientists do look for, in fact, is was there water available or in the past, or is there water available on that planet now? So far, we know that the Earth is the only planet we've been able to find that has actual liquid water. There are traces of water on Mars, indicating that at one point it might possibly have had life. So you know that water is essential to life. If you don't have water, you're not going to have life. Water is of major importance to all living things. You should have a general understanding of this by now. We need it to live. Other living things need it to live as well. If you don't water your plants, they're going to die. If you don't water your dog, they're either going to die or find another source of water. So definitely make sure you're taking care of your animals and plants. If our crops don't get a lot of rain and they're not irrigated very well, they're going to die. So this should be something that you know and can experience and see and observe in your own life. Up to 60% of the human body is water. We need it for our general cells to function, to decrease friction in between our joints and all that stuff. We use water for lots of things, lots of transport in our body. And then because we need a lot of water, because our body is made of a lot of water, we need to make sure that the quality of water is safe. If we have any microbes or sediments or stuff that might make us sick in the water, it's not any use to us. And again, remember, because water is a universal solvent, it often carries many things, both visible to our eyes and invisible, like chemical things, that can affect humans in a negative way, or anything that's being watered with it. The drinking water that we use should be totally clean. That's pretty agreeable. Pure and free of any disease-causing microbes. I know that I definitely don't want any microbes in my glass of water that I'm going to drink. And that's why it should be properly treated and disinfected before it's used for drinking purposes. Like I said, in our country, we are privileged to have a system that does disinfect and clean our water like this, but not everybody is so lucky. Where does the water come from? We've talked about this, so we're talking our freshwater sources. We have freshwater in glaciers, which is not listed here, or frozen ice. But as far as where our drinking water comes from, we get them from our surface water and our groundwater. Our surface water includes lakes, rivers, and reservoirs. Groundwater includes wells. And we can also get it through precipitation and runoff as well, like our surface water. A well is the way that we get groundwater, so it's a pump that brings the water from the ground to the surface. Ta-da, like that. And remember, groundwater, when it's stored under the ground, we call it aquifers. Big science word that we'll talk a lot about in Earth and Environmental. Surface water. Let's just remember the water cycle. We'll go over it pretty quickly. Actually, we don't have to go over it at all because we spent at least half of a day on it. Drinking water in the United States. So the United States has one of the safest water supplies in the world. Generally, you are unconcerned about the water that you drink. For the most part, you assume that it's safe because it has been noted as one of the safest in the world, though in recent years we have discovered that it's not as safe as we think. Microbial contamination of the water supply has led to highly publicized outbreaks of disease causing illness and even death. So how safe is our water is one of the questions that we'll answer today. Where did these infectious microbes come from, and how is the water treated now, and what's being done to make it even safer? So we've started actually disinfecting our water, and we'll learn about that with our UV radiation. But microbes can come in through the ground, soil, maybe pollution, especially if we're talking like manure or sewer gets into our water supply. That would generally lead to lots of microbes. Good. So here's the general flow of our water treatment plant. We're going the wrong way. Still going the wrong way. But we'll go through all of this again, and it'll be fantastic. So water treatment. Water treatment transforms raw surface and groundwater into safe drinking water. Most of us drink or use water that has been treated. Water treatment involves two major processes. The first is a physical, which removes any suspended solids. The second is a chemical disinfection. Coagulation is the first thing we're going to talk about. So coagulation is the physical removal of solids. It removes dirt and other particles suspended in the water. Alum and other chemicals are added to the water to form tiny sticky particles called floc, which attracts the dirt particles if the filter didn't catch them. This combined weight of the dirt and the alum, or floc, becomes heavy enough to sink to the bottom during sedimentation. So the first thing that happens to our water molecule is it comes from a lake or reservoir where it's unpurified and goes through a filter. That filter removes all the dirt or suspended particles that it can, but filters have a limit. So, to help catch some more dirt that maybe the filter missed, they put alum and other chemicals into the water to basically form a big sticky slime ball. That slime ball is heavy and then sinks to the bottom during what we call sedimentation. Here's an example of the water supplies being treated like that, coagulation. We're putting that flock in and trying to catch those sediments. Good. So sedimentation, there we go. Coagulation particles fall by gravity through water in a settling tank and accumulate at the bottom of the tank, clearing the water of much of the solid debris, and the clear water moves to filtration. So the next step after sedimentation is filtration. Sedimentation is when that flock falls to the gravity. It sinks down into the tank. Wonderful. This is often done outside in tanks like this. So this water is waiting, quote unquote, for the sediments to settle down at the bottom that have been coagulated. Our next steps here. First one, and I put little stars on your notes so that you're able to see these. If you're using the electronic ones, though, you'll have to find this as you go. So filtration is our next step. The water passes through some more filters made of sand and charcoal that helps remove even smaller particles. So the debris that's left in the water as we go through this process is getting smaller and smaller. We're getting finer and finer in our filtration process. So we filter again to get even more of those smaller particles out. The next step is we disinfect the water. So a small amount of chlorine is added, and other disinfectant methods is used to kill microorganisms that may be in the water. So these are our microbes that cause disease, like our cholera-causing bacteria, and I cannot remember the name of it, but bacteria like that, they're killed by the chlorine and the other disinfectants so that they're no longer in our water. Good. The very next step is storage. So water is placed in a closed tank or reservoir or water tower for disinfection to take place. Then the water flows through the pipes to the homes and businesses in the community. So that's the very last thing. So when you see water in a water tower, it's being stored there after disinfection. And then the next step is it goes into your house and out your faucet. So here we've got one of the tanks again that's storing water. This most likely wouldn't be your end storage of water. This could be where our disinfection is happening. There are a couple types of ways that we disinfect water. So again, the purpose of it is to make sure that we kill any of those microbes and bacteria that might cause disease. We generally have 3 methods for disinfection, and they're the 3 ones that we mainly use on a large scale, but there are other ways as well. So the very first one we already learned about, chlorination, and it's the most common in the US. I do believe, don't quote me on it, I can say with about 75% confidence that your water, if you drink town water, is chlorinated and not disinfected in any other way. But chlorine is the most common cost-effective means of disinfecting water in the US. That's why most of us use it. It's cost-effective. It's not that expensive. The addition of a small amount of chlorine is highly effective against most bacteria, viruses, and protozoa. But cyst, which is a durable seed-like stage of a microbe formed by the parasitic protozoa such as Cryptosporium and Giardia, can survive chlorine. Remember, we talked about Giardia and Cryptosporium as being parasites. Chlorine is added to water in one of 3 forms: in the elemental form as chlorine gas, in hypochlorite solution, which is bleach, or dry calcium hypochlorite. All 3 forms produce free chlorine in the water. That chlorine kills those microbes. Here's an example of one of such machines adding chlorine into the water. Ozonization. We are going to have to pick this up in another lecture. It'll be only 5 minutes though. Bye.